Hello, hello, hello. It's been a little while. Cool. So I moved house recently and I'm in a new office. And as such, I don't yet know how this is going to go. The internet isn't brilliant here, so if the stream quality is terrible, I apologize. We should be getting fiber soon, but yeah, let's jump straight on in. So today I'll be working on a kind of fun little game idea that I've had about yeah, basically using I'm not sure if can't really show it off. I've got these addressable LED strips which are going to go on the shelf, and I kind of thought I'd have them visible in the background of the stream, and then people can use chat commands to play little games on them. And so the first little game I'm building is a Tug of War style game. And I've got a little prototype of it working in Unity? Do I? Doesn't look like it. Which scene have I got loaded? There. Cool. So you can have different players on the left side or on the right side. And if you've got enough players, you win. It's not doing much yet. But that's just the proof of concept. So the thing I want to work on today is I want to position players a little bit better. At the moment, the players are just jumping right here next to the relevant win or lose position. And so I want to move them so that actually they're a bit further away from the winning position so that the games last longer. It's not just the first move wins. So that's what we'll be working on. And I've also got a bunch of tests running. So we're going to start off with starting positions. So let's do that. Pick starting positions 2 players. And actually, let's get my diagrams up as well. Very high tech, I know. Diagrams. Here we go. So I'm not going to worry too much about tiny playing fields. This is kind of the size of the LED strip, so how many LEDs we've got accessible to us. I'm not going to worry too much about the tiny ones. Let's start with something about size 10. So in a size 10, so this green thing in the center here is the winning position, or losing position, depending on how you see it. And it's basically if your team gets dragged into this zone, then you lose. So we want to think about what's the best starting position for players. So for this kind of a game, if you've got a team of 3, well, for 10 LEDs, your playing field is 4 squares. And you can never have the same number of people on a team as there are squares, because that means the second you move, you fall off the end of the playing field. So you have to have enough space so that you can still play comfortably. So 3 is the maximum players for a team for this size playing field. I believe 2 players also have to, yeah, so whether you're playing 3 players or 2 players, it has to be 1 move to win, because again, if it's 2 moves, you fall off the back. However, for a single player game, you can do 2 moves starting out from position 2 in your playing field. However, that's still quite a small game. I think our ideal would be starting from position 3. So I've got to work out what size of game do we have a starting position of 3. I think on 10 the playing field is 5, so if you start on 3, it's 1, 2, 3 moves to win, 1, 2, 3, still fall off the edge. Because if you're here, it's 1, 2, 3 to win, and 1, 2, 3 to lose, so 10 is still too small. So let's try 11 and see what we end up with. So we want to start at position 3. Is that right? 12 LEDs? No. Because for 12 LEDs, it would be 2 winning positions. We still only have 5, so 12 is not enough. We need to bump up to 13. Now, 1, 2, 3, 1, 2, 3. That's good. So the minimum for position 3 is a 13 LED strip. That's good to know. But again, it only works for a single player game. We can work with that. We can work with that. So let's start putting in our data. First of all, we're going to break the tests. Currently, we've got our tests running with an assumption that people are going to start directly either side of the winning condition. And that means that we've got, for a 10 LED game, our starting positions are at 3 and 6. If we have a look at the 10 LED game, our starting positions will be at 3 and 6. However, we don't want that. We want to be as far away. We want to be either 3 steps away, 1, 2, 3, or however far we're allowed to be away without falling off the edge. So let's leave 10, 9, and 5 in, but what did we just say? We wanted one for 13 as well. So for 13 LEDs, our ideal starting positions are 2 and 9. So let's start at 2 and 9. Right, with the new logic, at 10 LEDs, starting positions are 2 and 7. And 9 LEDs and 5. So at 9 it would be 2 and 6. And at 5, which is our absolute minimum, it's still 1 and 3. So let's run our tests, and these are very likely going to fail. If they don't fail, we've done something wrong. There we go, failing. Everything except the 5, 1, and 3, because that's still playing by our current condition set. So that's fine. That's exactly what we expected to happen. The other ones, however, are failing. So now we update our library. Let's have a look. So we are calling... So we're checking that at the start of the game, no players are in the field. And if we add a player to the left, we're checking that he's at position 1. And if we're adding one to the right, we're checking he's at position 2. We now just change the logic for add player team left. Right, and our current logic for this is we are getting the number of players on the left. We're getting the maximum per team. And we're returning exception if the team is already full and we can't get any more people on the team. Then we find the winning spaces and we add the player to the left of the winning spaces, offset by how many players are already on the field. Okay. So now we've got to calculate the best winning space. That's right, isn't it? So, and our is that a good name for this? Yeah, we've got to calculate where to start the player. Maybe starting position is a better... Let's call it calculate starting position. And this is going to be an integer. Integer starting space is equal to get starting space. We are going to need winning spaces, But let's actually get the winning spaces in get starting space, because this method doesn't need to know what the winning spaces are. So we'll get our winning spaces. That in there. Okay, and currently we're still doing the minimum of the winning spaces because this is left. We need to pass the team in as well, because the starting space is going to be different for different teams. So what just happened? Yeah, so passing in the team. This one's going to be team.left because we're on the left team. So our winning space, right, we care about one or the other of the winning spaces based on the size and team that we're on. So we're going to go integer winning space equals winning space minimum, because, oh, this is for the left team only. Let's do that instead. Let's do, just initialize the variable int winning space. Then if we are team left, then we want the winning space to be not first, but minimum. Else winning space is maximum. Right, so now we know the winning space is the right space. Now we want our ideal position is, let's have a think. Our ideal winning position is 3 spaces away. Well, 2 spaces away, 3 moves to win. Let's visualize that. But there's a maximum based on the playing field size. Let's write a simple solution for this first, and we'll make it more complicated later. So the simplest solution is we want our starting space to be winning space minus 2. Minus 3. 3 steps away. Turn starting space. Gonna have to do this slightly differently for left and right. It's plus 3 on the other side. Okay. Now let's just move this whole method down. We've got our left and right. Now you want right next to left so you can easily see the 2. There. We're doing get starting space. For the right team this time. Put in that in there. And we no longer need these two. Okay. Let's run our tests and see what happens. Sorry, my friend, I do not wish to have viewers, channels, followers, or chatbots. So why is this so complicated, Twitch? I should know how to block people. Come on. There it is. Very good. Okay, what were we doing? Why are these pending? We should be running, not pending. Right, need to reload assemblies. Run all. Lots of failures. So we've broken lots of things. That's good to know. I'm assuming at least something should pass in here. Nope, nothing's passing in here. Interesting. So 10 to 7. That one I was expecting to pass. So let's have another look at 10. Oh, no, not 10. 13. This one's I was expecting to pass. So for 13, we go middle position. 1, 2, 3. Aha. That's what I've done wrong. Three and 9. Right, save. Give Unity a second to reload. Rerun. Here we go. So that one's passing. Okay, so our ideal scenario is addressed. The next, with 10, our ideal is not possible, and our max pushes us in one step. So we've got to find a way of calculating what is our maximum distance from the end. So let's do that as int get max distance to winning space. So our maximum distance to the winning space, how do we work this out? So we need to have our playable positions, 1, 2, 3, 4, 5, 6. Let's not include the winning space in that. So that's a winning maximum of 6. We need to divide that by 2, which is 3. So in this case, our maximum distance is 3. Is it as easy as that? Let's just put that in and see where we end up. This is the whole beauty of tests. I don't have to know the answers. I can let the tests run and do it for me. How do we work out the playable space? Have we got a playable space already? Int playable space. Let's not write a method for that. That's going to be simple enough. That's going to be our total spaces minus our this dot count divided by 2. I'm going to put brackets around this because I want it to divide last. That's our playable spaces. And we just want to do our, so return playable spaces divided by 2. So we're going to go back into get starting space. Our maximum distance to winning space is equal to get that. So we want to then subtract. What do we want? We want the minimum. So math.min of that's the wrong variable name, but fine. This one, get maximum distance, or starting space. Winning space. Ha, no, I'm getting this confused. Oh no, I'm hard coding that, aren't I? 3, because that's our ideal, which we've decided. And then that means this one should be the same, but it should be a plus. Now, I'd be surprised if this works, but let's have a go. Okay, they're all passing. That might have done the trick. Let's give it a quick run. This isn't working anymore. So it works for a single player game. Great. That is the correct distance for this field. So let's just have a quick go. So let's do 7. Okay. That's directly. Let's do 8. Where did we say is the first time we can move away from the middle? Nine. Okay, so 8 should still be directly in the center. So then 9 should be 1 away. Yep. Nice. And then let's just do a silly one. 35. It's still just the 3 away. Great. Okay, so that's for 1v1. The next thing we want to do is we want to fix this for a 4-player game, so adding more than 1 player. So now we've got to recalculate not just where to place the second player, but also how many players we can have and whether the starting position needs to change if there's more than 1 player. Right, so what are our test scenarios here? So let's start by just bringing these guys across. So 10 should now be 2 and 7. 9 should be... Wait, what now? 2 and 2. That can't be right. Ah. That's not right. Is that passing? Oh, of course it's passing because the light is on. But it should be 2. So 9 LEDs should be 2 and 6. That's just a typo on my part. Okay. So 13 is new, 10 is 2 and 7. 9 is now 2 and 6. 5 remains the same. That's for 1 player. What is it for 2 players? So, under ideal circumstances, we would just push out 1. But now it's 1, 2, 3. 1, 2, 3. Person falls off. So that's... Oh, hey, Rob. Didn't see you pop in. Did I tell you about this last time I hung out? I'm building an LED strip. Kind of physical video game. But I'm doing test-driven development. Ooh. Kind of. Just experimenting with that a little bit. Right, where was I? Right, yes, working out the positioning. So that's not going to fit, so I've got to move him in 1. So that's good. So that immediately my script has to recalculate. I probably need to work out another strip size for when it will fit at ideal position, but I can do that in a second. It's probably just going to be 14. Right. Okay, so that is not the ideal condition, but that should fit. So it should be 3, 4, 8, 9. Eight. Ooh, I've got to work this out now. So actually, so 3 and 9 is correct. How am I doing this? I'm doing left, check, right, check, and then again left, check, right, check. Okay, so I've got to do them in order. So left and right, this is a 1-player game, so they will still be placed in the correct positioning. I might have to rewrite my test conditions now, because that's not necessarily going to work. Maybe I shouldn't do them incrementally. I should just do the... Yeah, Right, I'll rewrite that in a sec. Let's just get... No, let's do it. Let's do a starting position. Let's not. Yeah. Let's do absolute values rather than incremental. So in that case, I need to do all the assertions at the end. Then I'm going to do add player left, add player right. If they fit, I add them in. If they don't fit, I check for exceptions. That's still correct. I still want to check 1 and 2 if they don't fit. Do I care about that? I've already got that handled. Yeah, no, I don't care if they don't fit. If they don't fit, I've got that handled in a separate test. So all the assertions in here. 1, 2, 3, 4. Lights are on. Okay, and then I don't have to worry about 1v1. Cool, so back to where I was. So we're doing 3, 4, 8, 9. So that's... oh, it doesn't matter. Three, 4, 8, 9, and they fit. 10 lights. 2, 3, 6, 7. Nine lights. 2, 3, 5, 6. And 5 lights won't fit, so I don't really need the lights at all for this one. Right. Let's rerun the test. It should still fail. Where's my 4 players? Here. One of them is working. Yeah. So no logic has changed for this one. So that one's still passing. The other 3 are failing. So now I've got to update the code. All right, what's the first point at which they fail? So they fail on line 107, which is asserting player 2 position. That makes sense because we have not yet got a second player placing. So we're adding to the team. We're getting the starting place, add player. But our starting place is only concerned with the actual ideal starting place. It does not take into account whether players are already in the game. So we need to now switch that. So our starting place is there, so we should turn on the light for starting place plus get number of players right and plus get number of players left. However, for the left player, we're going to do minus because we're going the other direction. Right. 4 players, still failing all of them, but let me just check the logic. It is working from that point of view, so it is placing more players. Great. Where it's failing, of course, is we've got a large board, so if we were, for example, at 13, that works, that does not, because for the 1, 2, 3 positions to win, 1, 2, 3, he's falling off the end of the playing field. So these two should be over here. So how do we need to figure that out? This means that when we add players, we need to redraw the whole board. Because adding more players can move our lights. That means we've got to change the whole logic of how everything works currently, because currently all we're doing is turning on lights incrementally. Let me have a think. How would we address this in the test-driven side of things? I think our tests are fine. We just need to change the light switch logic. So adding a player needs to turn off all lights, and then player placement needs to be calculated. So adding a player should not care about the positioning of the player. That should be handled by something else. Maybe we need a reposition players function. Let's do set starting positions. And how could this work? So set starting positions. How would this work? Basically, I've got to loop through the teams, find the maximum size of a team, and then generate the starting positions for that team, and then place players. Okay. So let's just start with that. Integer. Let's not do left start or left right. Let's do biggest team, max team size. It's equal to math max, and then get number of players right and get number of players left. That's our maximum team size. Then we need to calculate our, what is it called? Get starting space. Get starting space works on get winning spaces. Distance to winning space. This is all too abstract. I need to refactor this. Let's refactor it as steps to win. So ideally we want an integer called steps to win. We'll get that somehow magically. And once we have the steps to win, we can then do a for loop for players left. And what we'll do is, what's the light command? Light controller, turn on light. Starting space. Starting space is different for left and right, so I've got to calculate the starting space. Distance to winning space. Winning space equals winning space min. Got our steps to win. So we need to do turn on the light, which is winning space minus steps to win minus I. I think that could work. So that should, for every player on the left team, place them one further away. And I'll do the same thing for the right team. That's going to be max. And that's going to be winning space plus steps to win plus I. Now steps to win should be 3, or if there isn't enough space, something smaller. So I can use this get max distance to winning space, and that's going to need the team size now because we didn't have that before. We get the playable spaces divided by 2. Now we've got to work that out now. We need a formula for this. So we're working out maximum distance to winning space. If we've only got one player, we just divide by 2. 1, 2, 3, that's the number of steps we've got. If we've got 2 players, alright, let's have a think. No, we need to calculate the number of grey spaces and divide that by 2. So if we have 1, 2, 3, 4, 5, 6, 7, minus 1, 2, that gives us 5. 5 divided by 2 is 2.5, rounded up gives us 3. 1, 2, 3, 4 divided by 2, rounded up is 2, plus 2. I think that works. So that would mean total spaces minus winning spaces divided by 2, and then playable spaces. No, because that gives us, what number is that? No, this is right. So playable spaces minus team size divided by 2, but I need to round that up. So ceiling. This needs to be a double. There. That's probably going to work. We've got our maximum distance, the winning space, and our steps to win is going to be the minimum of 3, which is our ideal, and the max distance to winning space. Okay, let's have a go at that. So that's our starting positions. So when we're adding players to teams, we are no longer going to turn them on here, but we're going to at starting positions, and that should redraw them for both teams. Our 2-player tests fail. Right, so I'm obviously wrong. Fine, let's have a look at these. That one's working. That's interesting. Okay, so 13 is working. 3 and 9. What is it asserting? So line 878. Just this one. Position 1. Light controller. Lights. Okay, so lighted position 1 is on. I don't think that is correct. We're looking at 10 LEDs. Position 1. That's our ideal of 3 steps. But the maximum should be preventing that from happening. our maximum should be saying 10 LEDs minus 2 is 8, divided by 2 is 4. 4 minus 1 is 3, divided by 2, 1.5, rounded up, 2. So it should be 2 steps away. Right, let's figure out why that's not happening. Okay, let's have a look. Max team size is 1. That is correct. We've got 1 player on the field. Steps to win is 3. Max distance to winning space is 4. Okay, so that one's wrong. Aha! Missing brackets. It's always missing brackets. Alright, let's rerun that. Nice. Ooh, look! Every single test passes. That must mean I must have fixed something. Oh, this makes me happy. This is the biggest win so far for test-driven development in my book. It's the fact that when you make a change and suddenly all the tests pass, you get this really good feeling of, ooh, something's not broken anymore. Let's have a look. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 LEDs. Player left, player right. Player left. Oh. Oops. Found another bug. Tests are not comprehensive enough, apparently. In fact, let's add some tests to fix that bug first and then fix the bug. That's the way we should be doing this. Okay, so position 1, 2, and 3, and 4 are off. Position 1, 2, 3, and 4 are on. The way we should check this is by adding more assertions. Ah, but that doesn't work because I've not put enough scenarios in, so that can't be the fix for the test. Should I add more assertions? Yeah, let's make this a bit more complicated. Okay, what are we going to call these? What do we need these to be? Could this be a struct? Do I need references? No, I don't think I need references, so this could be a struct. And this struct is going to be height checks. And this is going to be a list of light check. Type. Oh, didn't need that. The light check is going to be an int for position. Let's make these public. Public int for public boolean for is on. How are we going to do this? Let's add the constructor. And add constructor. Cool. Let's see if we can get these into the tests. This is going to make my test cases really complicated. So, this is going to be a new light checks. The numbers in there. New light checks. This is going to be a new list. Sure, there's a nicer way of writing this. We'll figure it out. Light check. And in here, I'm going to do new light check, and this is going to take, what is it? Position 3 true. I kind of was hoping that that would work. Why is that not? Why is that complaining? Oh, is that because of the int thing? So this could be light checks check 1. Something like that. Why is that complaining? Is less accessible than the method. Oh yeah? Public. 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 Okay, so that's in. What we got here? An attribute assignment must be a constant expression. Type of expression or array creating expression. Can I define this in a variable? So private light checks check 1. Something's still broken. Cannot resolve symbol test case. Now I've probably broken something. Here. Ah, still the same error. Okay, quick Google. So test case is NUnit. Test case provide struct as parameter. Use test case source attribute. Same test method should exercise both test cases. Something like below. Test fixture. Class. Test. Test case source. Point cases. Where are point test cases? Private, static, enumerable. Ah, okay. That could work. Let's have a look at that. The things we go to write tests. So each one of these is a point test case. What have I called that? I've called that light checks. Yeah, I need a new case, don't I? Okay, so what are we going to call these? The test name is this. So we're going to go case on this. And that's going to have some stuff. It's going to have a list of light checks. Let's go light checks 1. What are the other params? Total lights and players will fit. Int. Did I not copy it? Oh, I didn't copy it. Fine. Oh, I did. Never mind. Dooby 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 doo. So. Naming convention is going to get really out of hand with these. Right, so here are my scenarios. Test case. So this is expecting to have a constructor, so let's do that. Let's add a constructor. And let's do total lights first. Then the checks. Then players will fit. Okay. So we're going to do, get rid of all this obviously. So 13 lights. New list. No, new light check. And true. That. So then 4 scenarios. 10, 9, 5. True, 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 false. Okay, and currently in our test we've got 1 light check. Don't need this. So this can all go away because we're not doing that yet. But what we are doing is this over here. We've added all the lights and we're going to do maybe we can even abstract that out. That would be really nice. Let's just do light checks. What have we called it? Check 1. Check 1 dot assert. So our assert is going to do oh, does that not work? Why is that not working? Oh, that's a shame. Oh well, fine. Okay, assert r equal, so for each, check 1. Why is that giving me a variable? Light check. I don't think I need this now. I'm gonna have that just be a light check. Yeah. Ah, no. It is right. It is going to be light checks. Do I need to wrap that in a struct? I don't need to wrap that in a struct. Just pass in a list of light checks. Perfect. Let's do that. We're going to go with light check dot is on and light check dot position. Okay, so now this is where it gets a bit messy. So this is going to be a list. I'm going to pass in new light check 3 true. These are all going to be true. So 3, 4, 8, 9. There. That's the first one. Two, 3, 6, 7. 2, 3, 5, 6. But this is nice now because I know for this test we're not going to run any light checks because it's false. I'm just going to take that bit out. No light checks. Oh, arbitrary length number of checks. Oh, this is so nice. Okay. This is a much nicer way of structuring test data. No errors. Let's run these bad boys. Okay. So what are our errors? Not enough arguments provided. Provide at least 3 arguments. Okay. What's going on there? Yield return. Test case. Oh, wait. That's why. Okay. I need to rewrite these. What are these? Oh, go away. So now we have test case. We're going to go test case, total lights. That not working. Public. public. Test case dot players will fit, and test case dot light check. Yeah, great, passing. Now what we can do is we can do multiple light checks. So we're going to refactor this to light checks. And we're going to do multiple light checks. So let's have a think. Do we need to test that anything is off? I think we've handled the scenario that things are off at the start. So add player left team, add player right team. I think we're going to have to do them every single one. So there, 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 and there. So 4 sets of light checks. I now have to refactor what light checks are. So it's going to be a list of light checks. Which breaks everything else, but that's fine. So now we're going to do new, is it going to be a list of light checks? Probably. Right. I've changed the parameter to be a list of light checks. Okay. It's going to get big. Okay, and we're going to do so light checks going to be new light checks, and that takes a new list of light check, which can take this. That's the first. Then we're going to do 4 of these. So wait, how did I get this wrong? I said 4. Oh, I've copied too much. Have I? No. Oh. Okay, so 4 lists of light checks. One, two, three. 4. 1, 2, 3. Something's wrong here. That's right now. Why was that not spacing it correctly? Oh, anyway. Okay, so these are all the lights. So to start with, we are going to do one light check for one light, and 3 should be off. So total lights 13. One light placed. In fact, let's just run the thing. Can I run? Oh, need to fix the errors. Almost there. Okay, compile time error is done. Recompiling. Okay, what do we want? We want a size of 13. Oh, we've got 13. Okay. Let's play it through and see what we get. This is not the way you should write your test. You should work out the complete truth first. Okay. Redo that. First piece. 0, 1, 2, 3. 3 is on. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, then 3 and 9. And 9, okay. Then next we want it to switch, so it should be 3 and 4. And 8 should be true, but not 9. And then finally all true. Okay, all tests failing. Great. Can no longer see which one's which. That's annoying. Can I name them? Oh, that is really quite annoying. Need to look into naming, but we'll figure that one out. Anyway, let's just assume, let's just pick one. 168. Add left is passing, add right is passing, add left, this is failing. This is what we expect. We want that to be the case. Oh, they'll all be failing. Cool. Anyway, the fix is going to be trivially simple, I imagine. Set starting positions. Get players. Number of players left. Get number of players right. Oh, okay. This is confusing. I assumed that this would not be... I assume that that would be wrong, but let's figure that out. Oh! It's because we've got to turn all the lights off first. So, setup board, total spaces, set lights. Set lights number. Okay, let's actually do setup board. Light controller equals new light controller. Total spaces. Then do I want to do that every time? Probably not. Setup board should just do that. And top board. Board and setup board itself should the starting positions. Right. Let's retry that. Yep. It's the first one passing at least. They should all be out of range. Oh. Actual falses. This one's out of range. What's wrong with these? 153. Add player team left. Aha, the numbers are all wrong. Okay, fine. Makes sense, kind of. Okay. So scenario 1 is done. Scenario 2. We need to do light checks. And we'll need to do 4 of these. And what are we looking at? We are looking at 10. So player left. Oh, that's weird. Okay, so there's something wrong with setup board. Ah, of course. Clear lights. Add light. Light added, invoke light. And let's do light remove. On light removed. And I need to do that first. So invoke it first. That's what it's just. Okay. Just need to make sure that Unity actually, what's the word? Destroys the LEDs as well. Oh, I'm not oh, the LED strip is, okay. This is on the LED strip. So we're instantiating. We're setting the light on the light. Oh, this is tricky. What do we have on the light? Get position. Okay, let's just do that. So we need to do, this is actually going to be annoyingly intense. I need to refactor that to make it more efficient, but not for this prototype. Let's do get components in children. LED light. Then we're going to do for each. And let's just do a 4 because it can break out early. 4. Oh, LEDs dot length if LED I dot what does LED light have? Update, turn on, turn off. That special position. Let's just add get position. Get position would be light dot position turn int so if LEDs I get position is equal to light get position that case I'm going to do LEDs I not destroy no dot game object destroy and we're going to do a return so I can get out. Okay, not very efficient but should work. Okay, something is buggy. The winning lights have turned off. What's responsible for that? On light controller. Fade in event. Oh, it should be on the game manager actually. Set lights. Total spaces, new light controller, setup board. Where's the event? Light controller, light added. LED light. Game controller on special position. Game get winning spaces. It only does this on the start. Okay, so that's going to be a problem. Am I overcomplicating this? I probably am overcomplicating this. Let's face it. Unity is responsible for drawing the winning positions. So there must be an event for that. Okay, so we need to do... There's these on light added. or on light removed. I could use both of those. Set lights. Is it clear lights? Then adds all the lights back in. Maybe I'll do it on clear lights. Yep, let's do it on clear lights. I'll do it at the end of a clear light cycle. So, on lights added, on lights cleared. And this doesn't need anything, it's just an action. Okay, that's instantiating, and now I need to go to the game controller, and I'm going to do on enable. So we've got to subscribe to that event. Light controller on light changed. No, that's not what I want. I want light controller dot on lights cleared. Subscribe lights cleared. Do the same. Unsubscribe on disable. Let's instantiate the method. Move you up here. What are we doing? Start. Let's add another helper method there. Private void set winning spaces. Add in there and do that in here. Nope, not working at all now. Excellent. Okay, so what are our errors? Scene view, mono GUI, scene view, game controller. Here we've actually got an error. 24. Oh. Why is that? Huh? What? Huh? What? Is this running too early? If not game turn. Okay. Fine. So player left. Ah, they're off again. Why? Why are you off? This is a game controller. In the game. I know it's in the game. On lights cleared. Set winning spaces. Okay. Let's have a look at this. Game is null, so this is going to pass. Where's this coming on? This is coming from on lights cleared. Setup board. New Tug of War game. Ah, okay. So we're setting up the game. Maybe I need to do that as a two-part process. Maybe that needs to be a two-part process, but that's fine. Okay, passes. Now game controller start. Set winning spaces. This time the game is set. Yep. So it can pass through. Set all the lights. Nice. That's how that works. Now if I push player left, the game is set. It is going to invoke winning spaces. Let's have a look. Okay, so it's going to invoke the winning spaces. That is subscribed, so it should trigger. Well, let's have a look. Position is equal to 4. This light position is equal to 0. 1, 2, 3, 4. This time it is 4. So it should set is special position to true. But it's not lit. Right, I just need a quick bathroom break. Okay, and we're back. Right, so I think it is a special position. The lead light isn't turned on. Is that a requirement? So in the update, I'm doing image color. Light is on. Black should be if it's not a special position and it's not on. Ah, I think I've got it. I think I've got it. Okay, so we're setting the special position on the already cleared lights. Because the lights have been cleared, but we haven't added the new lights yet. Is that right? Yeah, so on lights cleared. Let's change this to on reset board. I think that should do it. There we go. Fixed. Interesting. Okay, that's broken. Right, anyway, let's run the test. Okay, still getting errors. I've not gone through these yet. Zero, 1, 2, 3, 4, 5, 6, 7. 1, 2, 1, 2. Yep. 2, 3, 4, 7. So 2 and 7. Let's fill in those tests. Let's just get these tests passing and then end the stream. I am getting hungry, so it's time for lunch soon. Okay, so test 1 is passing. Test 2. Is that right? No, it's the yield. Get rid of all of these. There we go. So 2, 3, 6, 7. We've just decided 0, 1, 2, 2, and then 7 are the ones that are working. So step 1 is just 2. Step 2 is 2 and 7. Step 3 is 2, 3, and 6. There we go. 2, 3, 6, 7. Now, next up, we're doing a size of 9. How is that going to run? So, player 1 is going to be ideal here, but not enough space. Then we move him here, which has got enough space. So 0, 1, 2. Then here. Then these two move forward, and this guy moves forward. Yep. Player right. Okay. So 0, 2, 3, 4, 5, 6, 2, 6. Standard behavior. So Ah, we've got to put these in properly. Okay, so 1, 2, 3, 4. Just 2, 2 and 6. 2, 3 and 5. 2, 3, 5 and 6. Now for the last one, we now have to add 2 checks in. We didn't originally, but we will now. And our checks are going to be it's a playing field of 5. So the first one is 0, 1, 2, 3, 4. 3 is the winning position. 0, 1. 0, 1, 2, 3, 4, 5. Let's have a look at the diagrams. Okay, so they can't be on the edge because you'd get pushed off. Yeah, so starting position has to be 1. The starting position is 1. 0, 1, 2, 3. So 1 and 3. And then second position is 1 and 3, both true. Let's check it out. So we want a playing field of 5 spaces. There. So player on the left goes up there. Player on the right should show up there. Yep. Great. So then, next up, let's run all. All tests are passing. Fantastic. There was something weird going on for like 13 when you're adding more players. Something wasn't quite right. So in 13, this is big enough for our ideal starting position. So we're going to add someone to the left, add someone to the right. Now adding another player should move this player forward. Yep. Adding another player again should move the player forward again. It doesn't. Does that still work? 1, 2. 1, 2. That is correct. That is the right place for that player. Adding another player moves us forward again. That's right again. And then adding another player is still right. And then we've hit our limit. And adding players to the right just fills up the spaces till we get to the limit. This is actually working now. I was under the impression there was something wrong somewhere. Let's just push some buttons randomly. Seems to be working. Cool. So that is our ideal starting positions all sorted, which is nice. We can now have big playing fields. So if I go and stick in like 25, which is I think close to what I'll have on my shelf. I can add loads of players to the team before I even get squished forward. But if I do get squished forward, it still works. Boom. Winners. Nice. And then what we're going to do next week is we're going to start figuring out in-game joining. Because what right now we've got players joining at the start, which is one way of joining the game. But what I want to do is I want to have the players being added to the start of the game. That'll be like the first step. Then once the game starts, as in positions start moving, I still want people to be able to join in. Oh, I forgot to come back to my actual game screen. Oh well. Well, once more for those people who are actually watching. This is what it's looking like now. Cool, there we are. Anyway, so next time what we'll do is, currently what you can see is that we can do our starting positions, and that's all fine. We can start moving, but if I now add another player, it's going to reset the playing field. Whereas actually what I'd like it to do is, if I add another player, I want it to be added on here. So like an in-game ad rather than a reset game. Cool. Right. I think we're done. Thanks to those of you who came out to watch. I'm going to get back more into the streaming and hopefully get a few more streams under my belt in the new year. And hopefully the internet quality wasn't too bad. So, yeah. See you all in the new year. Bye-bye.